In this lesson, we're going to go over Big Idea 3, Standard 6, and we're talking about balancing ionic reactions. Before we get to balancing, you need to know how to count the number of ions in an ionic formula. So we're going to start by talking about determining the number of ions in a compound. So first, when we have an ionic compound, the subscript tells you the number of ions. Let's say my ionic compound was Al2S3. These subscripts tell me how many of each ion I have. I would have 2 aluminums and 3 sulfurs. 2 aluminums, 3 sulfurs. Number 2, what if we have parentheses? Subscripts in parentheses get multiplied by the subscript outside the parentheses. Let's say I had magnesium nitrate, my formula MgNO3, 2. So just like a number outside the parentheses in math, it gets distributed to everything inside. Same thing in chemistry, but it only goes to what's in parentheses, so it wouldn't go all the way to magnesium. It is going to get multiplied in, and it is going to get distributed to both the nitrogen and the oxygen. Remember, if there's not a subscript, that means it is 1. So the 2 doesn't go all the way to magnesium. Magnesium doesn't have a subscript, so I just have 1 magnesium ion. 2 times 1 gives me 2 nitrogens. 2 times 3 gives me 6 oxygens. Last rule to know, when we balance reactions, we are going to add something called a coefficient. A coefficient multiplies the number of every ion in the formula. So let's say my formula was calcium hydroxide. It might have a coefficient of 3 before it. When we go to count the number of atoms, this 3 is going to multiply every ion in the formula. It goes to calcium, it goes to oxygen, and it also goes to hydrogen. And again, it multiplies. So I have 1 calcium, 1 times 3 is 3. I have 1 oxygen, but here's where you have to be careful, because remember, the subscript also multiplies in. So based on my subscript, I have 2 oxygens times 3 would give me 6. Same thing with hydrogen. It has a subscript of 1. Let's do rule number 2 first. Subscripts in parentheses get multiplied by the subscript on the outside. 2 times 1 is 2. That gives me 2 hydrogens. The coefficient also multiplies. 2 times 3 is 6. That gives me 6 hydrogens. Now that we know how to count the number of atoms in a formula, we can talk about balancing reactions. Why do we balance reactions? Reactions must have the same number of ions on each side of the arrow. So let's say I had the following reaction: 2H2 plus O2 yields 2H2O. Let's check to see if this reaction is balanced by counting the ions on each side of the arrow. Subscript tells me the number of ions that I have. I have 2 hydrogens times a coefficient of 2 gives me 4 hydrogens. Here I have 2 oxygens. On the right side of the arrow, 2 times 2 gives me 4 hydrogens. If there's not a subscript, we assume it to be 1. 2 times 1 gives me 2 oxygens. So this reaction is balanced. I have 4 hydrogens on each side. I have 2 oxygens on each side. A reaction is balanced if we have the same number of ions or atoms on both sides of the reaction. 2 tips for balancing. It wouldn't really work with that first example because it only had hydrogen and oxygen, but typically you want to balance hydrogen and oxygen last. And I'll show you an example of why in just a minute. Hydrogen and oxygen should be balanced last. And another tip that's going to make your life much easier: balance polyatomic ions as a single unit. And again, once we get to an example with a polyatomic ion, I'll show you what I mean. First example. Fe2O3 plus H2 yields Fe plus H2O. We said balance hydrogen and oxygen last, so that means I'm going to start with iron. I have 2 irons on the left. The only thing you can do to balance is add a coefficient in these blanks. You could not add like a subscript of 2 here. You can't change the formulas. So I have 2 irons on the left. I need 2 irons on the right, so I can add a coefficient of 2. Next, let's look at oxygen. I have 3 oxygens on the left side of the arrow, but only 1 oxygen here. The only way I can get in balance is by adding a coefficient before the formula. If I have 3 oxygens on the left, I need 3 oxygens on the right. Now 3 times 2, that gives me 6 hydrogens. Over here, I only have 2. So what number times 2 will get me to 6? I would need a coefficient of 3. We can either leave this spot blank or we can add a 1. Last check, go through and count your atoms and make sure they definitely are the same on both sides. 1 times 2 gives me 2 irons. 1 times 3 gives me 3 oxygens. 3 times 2 gives me 6 hydrogens. If we balance this correctly, we should have the same number of ions on the right side of the arrow. 2 irons. 3 times 2 gives me 6 hydrogens. 3 times 1 gives me 3 oxygens. I have the same number on each side of the arrow, so that means my reaction is balanced. Number 2. So this reaction isn't ionic, but it's actually a very good practice. This is a combustion reaction. So here is one where it's really important that we balance hydrogen and oxygen last. The reason being, let's say you balanced your oxygens first. Then you went back and had to balance carbons. So you put a coefficient here. Well, as soon as you balance the carbons, you're also going to change the number of oxygens. So we want to do those last. So if hydrogen and oxygen are last, looks like we need to start with carbon. On the left side of the arrow, I have 3 carbons. Here I only have 1. Next, let's go to hydrogen. 8 hydrogens. On the right side, I only have 2. Well, what number times 2 will get me to 8? 4. Here's where we have to be really careful. I have oxygen in multiple places. Let's count the total number of oxygens. 3 times 2 gives me 6. 4 times 1 gives me 4. That means on the right side of the arrow, I have a total of 10 oxygens. So on the left side, I need 10 oxygens. So I can add a coefficient of 5. Last up, let's go through and count my ions. Again, I can either leave this blank or I can put a 1. 3 carbons. 1 times 8 is 8 hydrogens. 5 times 2 is 10 oxygens. Let's make sure we have those same numbers on the right side of the arrow. 3 times 1 gives me 3 carbons. 3 times 2 gives me 6 oxygens. 4 times 2 gives me 8 hydrogens. 4 times 1 gives me 4 oxygens. 6 oxygens in carbon dioxide, 4 in water, giving me a total of 10. 3 carbons on each side, 8 hydrogens on each side, 10 oxygens on each side, so we're balanced. Let's try one more. Aluminum bromide plus potassium sulfate yields potassium bromide plus aluminum sulfate. So here's one with a polyatomic ion. So we're going to balance the polyatomic ion as a single unit, and I'll show you what I mean by that. Let's look for things that aren't balanced. So starting at the left, I see that I have 1 aluminum, and then on the right side I have 2 aluminums. So let's add a 2 here. 2 aluminums on the right, 2 aluminums on the left. One thing that I like to do when I'm balancing is let the problem lead me, so I know what I'm going to balance next. As soon as I balanced aluminums, that changes the number of bromines. So now I'm going to try to balance the number of bromines. 2 times 3 gives me 6. Over here I only have 1, so I'm going to add a coefficient of 6. Again, let it lead you. I now balance these bromines, but that changed the number of potassiums. Now I have 6 potassiums. Over here I only have 2. So what coefficient times 2 gives me 6? 3. Think of this sulfate like one single ion. Balance it like a unit. Instead of counting the number of sulfurs and counting the number of oxygens, let's count the number of sulfates. I have 3 sulfates. 3 sulfates. So we're balanced. Last step, let's go back and check our work. 2 times 1 gives me 2 aluminums. 2 times 3 gives me 6 bromides. 3 times 2, 6 potassiums. Imaginary number 1, 3 times 1 gives me 3 sulfates. Let's go to the right side of the arrow. Coefficient multiplies everything in that formula. 6 potassiums. 6 bromides. 1 times 2 gives me 2 aluminums. 3 sulfates times 1 gives me 3. Check to make sure that every single ion in your reaction is the same on both sides of the arrow.